welcome back. So what we're looking at today is lesson 6, what about other bases? So let's go ahead and jump right in. We're looking at exponent rules with bases other than 10. So remember I mentioned that these are going to stay the same. We're still going to have those same kind of rules. So Lynn, Noah, Diego, and Elena decide to test each other's knowledge of exponents with bases other than 10. They each chose an expression to start with and then came up with a new list of expressions, some of which are equivalent to the original and some of which are not. Choose two lists to analyze. For each list of expressions you choose to analyze, decide which expressions are not equivalent to the original. So if we look at Lynn's, she's got 5 to the negative ninth. Here's her list. So she's got 5 to the negative third to the 5 to the third to the negative third, negative 5 to the ninth, 5 to the negative sixth divided by 5 to the third, 5 to the third to the negative second, 5 to the negative fourth divided by 5 to the negative fifth, 5 to the negative fourth times 5 to the negative fifth. So if we look at what each of these represent based on our prior knowledge, based on all those rules we know, when we take an exponent to another exponent, we multiply them. So 3 times negative 3 is going to give us 5 to the negative ninth. So that one works. For the next one, if we have the negative out front, the exponent is not negative, and when we have a negative exponent, that's not affecting it. So this one does not work. It's negative, not positive. And we want a positive solution. All right, next one we have 5 to the negative 6 to 5 to the third. Remember, we subtract exponents. So negative 6 minus 3 is going to give us negative 9. So we would end up with 5 to the negative third. So this one works. The next one, just like the first, we'd multiply them. That's going to give us 5 to the negative 6. Does that work? Nope. All right, the next one we're subtracting again. So we have negative 4 minus negative 5. If we take negative 4 minus negative 5, we're going to get a positive 1. So that one does not work. And then last but not least, remember we add them when we have two bases. So negative 4 plus negative 5 will give us 5 to the negative ninth. So there were 3 that did not work and 3 that did work, that were equivalent. All right, Noah's original expression was 3 to the 10th. Erase that so we can see it a little better. And here's his list. He has 3 to the 5th times 3 to the 2nd. 5 and 2, are those going to give us 10 if we add them together? Nope, that's 3 to the 7th. All right, the next one, 3 to the 5th to the 2nd. If we multiply 5 and 10, we get 3 to the 10th, which is what we want. Here we have 3 times 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 3. Lots of 3s. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 of them though. So this is 3 to the 10th. Here we have 1/3 to the negative 10th. If we take 1/3 to the negative 10th, is that going to give us the same thing as taking 3 to the 10th power? Interesting enough, it will. So that one ends up working. The next one, 3 to the 7th and 3 to the 3rd, if we add those together, we get 3 to the 10th. And this one here, if we take 3 to the 20th divided by 3 to the 10th, subtract those, 20 minus 10 is 3 to the 10th. And this one here, subtract again, 20 minus 2 is 18, not 10. All right, Diego's expression is x to the 4th. Here's his list. Well, we know this one right here is definitely going to work because there's 4 x's. We have x to the 8th divided by x to the 4th. 8 minus 4 is 4, so that one works. Negative 4 minus negative 8, cross and stab would be plus. Negative 4 plus 8 is positive 4. So I'm going to put another x to the 4. This next one, we have a negative 4 minus 8, which will give us a negative 12. So that one does not work. X to the second, multiply those, we'll get x to the 4th. 4 times x, nope, definitely doesn't work. That's just a plain old 4x, which is very different from x to the 4th. And then here we'd have x to the 1st times x to the 3rd, so 1 plus 3 is x to the 4th, so it works. All right, Elena's original expression is 8 to the 0, and her list is, now remember, anytime we have any number to the power of 0, the answer is always 1. So we know 1 works, because it's 1, so that's equivalent. 0 does not work. It's not 0. If we take 3 plus negative 3, that's going to give us 0, so it works. Or give us 1, because it'd be 8 to the 0, so it'd give us 1, so that works. Subtract the 2's, that'll give us 8 to the 0. That also works. 10 to the 0 works, and 11 to the 0 works. So all of these equal 1. The only one that doesn't is 0, and 8 to the 0 does not equal 0. Biggest mistake that people make, though, because typically when we see that 0, we think, oh, multiplication's involved, it's automatically 0. Nope. If it's an exponent, it means it's automatically 1. So be careful with that. All right. Your keyword for this lesson is rational. Rational. If you guys have any questions, feel free to ask. Have a great day. Bye, guys.